Hello, everyone. Sometimes you see someone that's very important to you, and then you just feel something in your chest. You're like, oh my god, oh my god, so beautiful. What am I feeling? Oh my god. Other times you get really, really tired, like in PE class. You're all like, Miss Rhea, I can't anymore. I can't, no. Just my chest. Oh my god. There's a feeling in your chest in these situations. And in this session, we are going to talk about why that happens. Science fam, my name is Sir Ramon, and this is Science with Sir Ramon. Alright, so first things first, let's begin with a few hit singles. So if you know these songs, hit it. You're probably alone in your room, so it's okay if you sing along, stuff like that. So what's this song? What's this? Can I hear it? Can I hear it from you? Mm. All right. Okay. So you got that one, hopefully. Next, we have this. Do you know what music video this is from? Clue. It's Adele. Anyone? Can I hear it? Can I hear it? Okay. Next, we have this from the OPM scene. Where are my indie OPM people at? From Mooney Mooney. Hey, can I hear it? What's this song like? Okay. So what do these songs have in common? There's a central theme to them. So between all three of these songs, the central theme is the heart. It is at the heart of these songs. And that's our topic for today, the circulatory system. It's specifically for the transport and defense of our body. So what does that mean? Let's get into the details of this. So first things first, these are our objectives for this session. We're supposed to investigate the heart rate under different conditions, identify the factors that affect the heart rate, relate the parts and functions of the circulatory system, trace how blood flows through the body, and discuss how the circulatory system reacts to different conditions. So everything about the circulatory system. So let's go. The heart, the thing in your chest, it keeps you alive. But how? What it do? So that's basically to pump blood around the body. It's just a pump. It just pumps that fluid around your body. And we're going to talk about what's so important about this fluid and why it's important to keep it flowing around your body. But first, what does your heart beat for? Okay, your heart beats fast or slow depending on certain conditions. And your heart beats so that it pumps the blood around your body. Okay? What makes it beat faster then? So it beats faster whenever your body needs the blood to get to the places faster. Okay? The more your body needs blood, the faster your heart has to work. So in order to figure out how fast the heart is working, we need to feel the pulse. It's the feeling of a beat. It's when your blood vessels are actually throbbing. So again, in order to get your pulse, you have to be able to feel it. So usually, we don't use our thumb. Our thumb has its own tiny pulse. We use our pointer finger and middle finger. You just make a scout sign like this. And then you have two options. You have under the neck, just under the jawline. If you press, you should be able to feel a dub, 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 dub. The other option is on your wrist. So here, near the thumb, underneath the thumb, if you can feel a little ridge there, you have to go press on that ridge. See here? So when you press on that, you should feel a dub, 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 dub. Okay? So that's your pulse. It's the throbbing of your blood vessels because your heart is pumping the blood through the vessels. Alright, so when we count this pulse, in a certain time frame, we get what we call the heart rate. It's the number of the heartbeats per minute. So a normal heart rate is around 60 to 100 beats per minute. So the question is, are you normal? Is it within that range? If your range is about 100 BPM or so, that's still normal, but that means you're not that physically fit. If it's around 60 or 70, that means that you've been working out, you've been exercising, or your body just has a naturally good metabolic rate. So again, the lower the heart rate, generally the more fit you are, as long as it's within 60 to 100 for your resting heart rate when you're not tired. Okay? If your heart rate when you're at rest is less than 60, that means there's a serious problem with your circulatory system, with your heart, or you're a witcher. So Okay, so what affects the heart rate? So a bunch of stuff can affect it. Physical activity can make your heart beat faster because your body needs more from the blood. The things that the blood transports, the oxygen, the nutrients, it needs more of those when you are exerting effort. Body temperature can also affect your heart rate. If your body temperature is too high or too low, the heart rate increases to try to normalize the temperature. And of course, you guys should be no stranger to this, emotions can affect heart rate. So even if it's something in here, it can affect what's in here. Alright? So again, strong emotions, physical activity, and body temperature can all affect heart rate. But what happens when your heart stops? That's the clinical definition of you being dead aside from brain dead. So what happens when it stops? Usually, a heart stops during what is called cardiac arrest, and that's actually an electrical malfunction. What does that mean? Your heart is a pump, and that pump knows when to pump based on electrical signals called nerve impulses. So your nerve impulses, if they get disrupted due to an electrical malfunction, your heart stops getting signals to beat. Then your heart stops beating, your blood stops circulating, and then it's just trouble for your entire body. How much trouble? How long can you survive when your heart stops? You only have a few minutes, around 2 to 5 minutes, before brain damage occurs. So that's the scary thing. Your brain has all of your processing power, all your thoughts, all your memories, all your emotions. So when you get brain damage, that's the dangerous part of cardiac arrest. Your organs and your limbs are surprisingly tough. Most of them can survive for more than half an hour. So it's the brain that we need to take care of. It's the brain that needs to receive oxygen and nutrients from the blood continuously, or else it might suffer irreversible damage, and it will damage who you are on a base level. So again, minutes before brain damage and more than half an hour for your organs and limbs. Next, let's tackle the question, do different organisms have different heart rates? For us people, we have around a certain range of heart rate, 60 to 100 beats per minute. What about mice? They're so tiny. What do their tiny, tiny hearts do? What about elephants? They're huge. Do their hearts beat more or less in order to support their huge girth? Okay? So the answer is that it's actually an inversely or indirectly proportional line, meaning the smaller something is, the faster the beats per minute. You can see here that the mouse, small as it is, needs to beat more times per minute because it has a tiny, tiny heart in its tiny, tiny body, and it tends to have much more range of motion. It's more agile. A mouse has little twitchy movements. It's more agile. It needs more pumping of the blood relative to its body. So there's more beats per minute for tiny, tiny things. For big things like elephants, generally they have less beats per minute because they have huge hearts. An elephant heart is very, very big. And since they're big, lumbering creatures, to conserve energy, they generally have slow, bulky movements. And that slow, bulky movement only requires a certain amount of the blood flowing, of which there is a lot, so your heart does not need to beat fast, it just needs to beat strong. So for your big things, they have less beats per minute, and for your small things, they have more beats per minute. Alright? So don't forget that about heart rate. Now let's talk about the roles of the circulatory system. What does the circulatory system do? Again, it's for transportation and defense. What exactly does it transport and defend? It transports nutrients and important gases, and it defends against foreign invaders for our body. So our body is composed of multiple organ systems, and they all need nutrients and gases, specifically oxygen, in order to function. And your body can't function well if it's getting invaded by stuff like bacteria and viruses, which is why we have to have this kind of class instead of face-to-face, viruses. Alright, so your circulatory system is very crucial for your survival. So what are the parts of our circulatory system? Systems always have parts. So there's three main categories for the circulatory system. You have the blood vessels, the little tubes inside, the heart, the pump, and the blood, the thing that it pumps. So let's go through this one at a time. For your blood vessels, they are transport tubes. They just transport the fluid, the blood, all around your body. Okay? So you have three types of blood vessels. You have the arteries, which take blood away from the heart. Again, your arteries, symbolized here by red big vessels, take blood away from the heart, towards the body or towards wherever it needs to go, while your veins take blood pabalik or back to the heart. So generally, all veins take blood back to the heart. In the middle of arteries and veins, the third type of blood vessel is the capillaries. They are composed of capillary beds, and they are very small. They're very tiny because they are made for exchange of nutrients and gases. Again, your circulatory system wants to transport nutrients and gases to different organ systems. So it needs very small capillaries because these small capillaries have a lot of surface area. Surface area is basically how much surface there is on the thing, and the more surface there is, the more area for exchange in and out of the vessels. So these tiny capillaries maximize surface area, allowing for more exchange of those nutrients and gases. Don't forget, arteries away from the heart, veins back to the heart, and capillaries, they're small for exchange. Excuse me. So don't get confused. We have the pulmonary artery, a very specific artery that takes deoxygenated blood going to the lungs. So it's away from the heart going to the lungs. Your pulmonary vein takes blood back to the heart from the lungs. So this is just to clarify. Some of you may have heard that arteries carry oxygenated blood. However, not all arteries do that. Pulmonary arteries carry deoxygenated blood. Okay? So what about the term pulmonary? We'll get to that in a bit. So double circulation is the method of circulation in most mammals. So that includes us. We are mammals. So there's two circuits in your circulatory system. There's the pulmonary circuit. Pulmonary signifies that it's related to the lungs and the respiratory system. That will be our next topic. So again, just remember, pulmonary, it's related to the lungs. So the pulmonary circuit in this diagram is the circuit between the heart, then the lungs, and back. So again, if your blood's going in a circuit between your heart and your lungs and back, that means it's called the pulmonary circuit. The other circuit is the systemic circuit because it your blood circles around the body systems and the heart. So the systemic circuit is from your heart to the body and back to the heart. So again, two circuits, the lung circuit, the pulmonary circuit, and the body circuit, the systemic circuit. So don't forget, two circuits in mammals, just for mammals. So the heart is literally just a pump made of muscles. So wala siyang kinalaman sa love. It means that the heart is just there to pump your blood through your body. The most it has in common with love is that love, being a strong emotion, can affect your heart rate. But that's it. Love comes from here, not here. Okay? So talking about the heart, how does it pump blood around the body? It has many components. We'll go through this one by one. Let me just move where my face is so that you can read everything perfect. So we have what we call the atrium or the atria. These are compartments of your heart that receive blood. Where are they? Follow my cursor. So there's the right atrium here and the left atrium over here on the other side. But wait, why is the right there and the left over there? Why is right over here? If you look at my cursor, it says that's the right atrium and this one is the left atrium. Isn't that mixed up? Did they get their directions wrong? So let me just explain. So right now, I'm facing the camera and I'm talking to you. If I raise my right hand, this is my right hand. For you, it seems like it's your left, but it's my right. So if you cut open my heart right now, the right side of the heart is on this side, whereas the left side of the heart is on this side. It is flipped because we're looking at a certain diagram. That's, for example, if you cut open my heart right now. My right side is here, and my left side is here. So let's just get that out of the way before we move on. So again, the directions are flipped. Right side over here, left side over here. So the right atrium and the left atrium, they receive blood from outside the heart. The right atrium receives blood from the biggest veins in the body. We call them the vena cava. These are very large veins. We have two types, the superior vena cava over here, you can see here, superior vena cava, and the inferior vena cava down below. So superior and inferior don't mean that one is better than the other. It just means superior is coming from up top and inferior is coming from down below. So the superior vena cava takes blood back to the heart from everything above the heart. So everything from my head going back to the heart has to go through the superior vena cava. The inferior vena cava on the bottom takes blood from my legs and everything down there up towards the heart. So once again, superior from up, inferior vena cava from below the heart. And both of those lead to the right atrium. Once the blood's in the right atrium, the deoxygenated blood in the right atrium will be pumped by the right atrium through the tricuspid valve. So a valve is just a one-way gate to prevent the blood from going back to the previous compartment. Again, it prevents backflow. Valves prevent backflow. So after the tricuspid valve, it goes into the right ventricle. So again, your ventricles pump blood out of the heart. Your right ventricle, in this case, pumps it into the pulmonary artery, which takes blood away from the heart and towards the lungs. Again, pulmonary, it's related to the lungs. So the pulmonary artery will take it to the lungs. After the blood exchanges gases with the lungs, it gets oxygen, and then it goes back to the heart through the pulmonary vein. Again, a vein takes blood back to the heart. It goes into the heart through the left atrium. So again, your pulmonary veins circle the blood back into the left atrium. So after the left atrium, your blood gets pumped through another valve called the mitral valve. And that valve prevents it from backflowing into the atrium so that it stays in the left ventricle. So in the left ventricle, it pumps really hard so that it goes through the aortic valve and into the largest artery in your body, what we call the aorta. The aorta is the largest artery that leads it into the systemic circuit. Again, from your left ventricle, your oxygenated blood gets pumped out into your body through the aorta, the largest artery. And that is the nutshell of how your blood flows through the heart. Okay? So I hope you guys try tracing the flow of blood. That's part of your brainstorm discussion, tracing the flow of blood. Sometimes mnemonics might help. For example, right receives deoxygenated and left leaves oxygenated. You can make some sort of sentence with that so that you can remember that the right atrium receives deoxygenated blood while the left ventricle pumps out oxygenated blood. So we're going to take a break because up next we're going to talk all about blood. For now, you can take a break so that you don't get overwhelmed with circulatory system. Okay? So that's it for video number 1. I'll see you guys in the next video. See ya, science fan.